It's the 20th. And this is just a continuation from yesterday. So we are converting point slope into slope intercept. It's a pretty common thing to be asked to do. Slope intercept is useful in a lot of ways, but not always easy to come across. Point slope is not useless, but less useful, but very easy to get. So that's why, like point slope, we write because it's easy, and then we convert to slope intercept because it's useful. So yesterday during the little mini lesson, I showed you just simple examples like this. So like if we had y minus 6 equals 3 times x plus 2. Okay. So that's in classic point slope form. What would we do first? I won't be offended if you don't remember, but you really should. Thank you. We distribute first. All right, so the parentheses need to go bye-bye first, and then we'll move that 6 across when we're all good and done. So I'm going to start by taking the 3 on the outside and distributing it through like this and like this. And I'm going to wind up with y minus 6 equals 3x plus 3 times 2 is 6. And then you see you get right at the doorstep of slope intercept, but the off piece is that minus 6 is over there pestering the y. So to move him, you just add him to both sides. You don't have to show your work on something like this. So I sometimes won't, but in this case, I certainly will. So I'm going to add 6 to both sides, and I get y equals 3x plus 12. Okay, so there it is in its useful form. The line starts on the y-axis at up 12 and has a slope of up 3, right 1. So, and that has a lot of applications in mathematics. So that's what we kind of worked on yesterday real quick. What I wanted to spend a little time on with you today is what happens when it's a little bit of a less comfortable process. And what's going to make it a less comfortable process is when the number right here, the green number, is a not very friendly fraction. Okay. And I did show you an example yesterday that not all fractions are like that, right? If I put like a 1/2 there and I had to multiply a half by like an 8, that's child's play. Half of 8 is 4. But not all fractions roll like that. So let's take a look at something, bless you, like this. There is going to be a set of basic skills that you're going to be expected to use. It's as always has been the case. If I lose you, it's your job just to advocate for yourself and ask. Chances are, if I lose you, I lost somebody else, and they will thank you for being brave and asking. Okay, since they're too chicken. So I'm going to start by doing what I always do, and I'm going to distribute. And right away, I'm going to encounter a dilemma, a problem, a lack of compatibility. So this time, when I take the number on the outside and I distribute it through, that second arrow is going to be a problem. It's not a big problem. It's just a problem. So we're going to be left with y plus 5 equals, of course, 1/4 of x. It's the next one. What's a fourth of 5? You can, but I mean, right. I know what you're saying. Like it doesn't come out pretty. Like if I asked you for a fourth of 4, you'd say 1. If I asked you for a fourth of 20, you'd say, oh, that's easy. It's 5, right? But the trouble here is that the whole number that I'm circling in red cannot be divided evenly by the bottom of the fraction that I circled in red. In a case like this, don't panic. What we're going to do, keep it simple, is we're going to, in our mind, we're going to think of the 1/4 as being multiplied by 5 over 1. Don't make a big deal out of it. When you multiply like this and you go top, top, bottom, bottom, what's 1 times 5? 5. And what's 4 times 1? 4. But we're not out of the woods yet. That's not the part that causes people stress. It's easy. Like you just put it over 1 and slab it together. It's easy. It's this part. Because what I have to do now is subtract 5 from both sides. And this is where I really need you sharp. When I subtract 5 from both sides, um, I'm going to subtract 5 on this side. And I'm going to do something here that we're going to need to talk about. Watch out. I'm going to subtract 20/4 on this side. And if you're going to get lost, it happened just now. The question becomes, what are you doing? Like, where did that even come from? Here's my thought on the matter is I know and you know that to add and subtract things, if they're called fractions, they have to have the same denominator, right? So let's walk through the logical process of what the human brain goes through. So I'll go back and I'll just subtract 5. But we have a dilemma. If I asked you to do 5/4 minus 5, here go the steps that your elementary school teachers, long before you met me, probably taught you. Some random day in March when you were in like fifth grade. Here it goes. Step one, they taught you that you have to make the 5 into a fraction. So the metamorphosis looks like this. The 5 becomes 5/1. But then after he or she got you to do that, then they also explained to you that you still can't do this problem because the bottoms aren't the same. So you need to take the fraction, the one that's not agreeing with the other, and make them agree. What do I want this number that I just circled in yellow to be? If I want it to be a 4, I have the power to make it be a 4. I'm going to multiply it by 4. That's easy. But as you know, with fractions, if you do it to the bottom, you have to do it to the top. And so it's at that point that the metamorphosis is complete. 5/4 now has a mate. I can subtract 20/4 from 5/4. And that's why I did what I did, is because I need the bottoms to be the same so that the tops can be added together. So back then to the other page, you see now over here why I didn't want to write -5. I wanted to write minus that version of 5. 24th still equals 5, but it has the right bottom. What is 5/4 minus 24ths? I mean, we know it's going to have a 4 on the bottom, right? What is 5 minus 20? So we have minus 15/4. We're done. That means that if we were asked to graph this, it would be one of those tweeners. You've seen these a long time ago where we have to start on the y-axis between two whole numbers. That's no big deal. We're not going to graph this once today. We're just going to get used to the mechanics of it. So that's an example of how a not cooperative fraction can greatly affect your work. Okay. Watch out for those. I'm going to show you an example of another fraction problem, and you're going to tell me if it's a friendly fraction or an evil fraction. That last example was an evil fraction. I'll leave you to decide on this one, how you feel about this one. What's your take? You like that fraction, or do you fear it? Well, let me get some work out of the way while you give me the silent treatment. So let's do y minus 2 equals, and I never have ever in the history of my teaching career had anyone ask me how to do the first yellow arrow. It is quite literally just sticking two things together. So that's just going to be 7/5 times x. Never has anyone said, how did you get that? It's this one. It's the red arrow. Is this a good math problem we're about to do, or is it going to result in a fraction? Let's look at it. Let's look at it. Let's take it off to the side and let's look at it with our inspector glasses. 7/5 times 5. See anything good? I do. I'm with you on this one, Embry. I see a 5 that's in the upper floor and a 5 that's in the lower floor. And last I checked, those can cancel out, leaving the answer as what? So it's just -7. That, my friends, is an example of a friendly fraction. That's the kind of fraction that we don't fear, because the number on the bottom of the fraction is going to get canceled out with the whole number that it's attacking. Nice. So that's not a fraction where I got to go make common denominators. Nope, this problem's almost over. What do I do to finish? I just add this 2 across and I'm done. So what's my final answer? Done. Okay, let's do another one. And you tell me, as initially early, I would like you not to silent treatment me. I want you to give me your initial impressions as to whether it's a friendly fraction or an evil fraction. Okay. I see you shaking your head. Does that mean you don't like this fraction? I agree with you. I don't like it either. I can see the writing on the wall. I can see the fact that this number that I'm circling in red says, I'm sorry, but I cannot be divided evenly by the number you're about to attack me with. So that's when we know that we can't avoid that we're going to have a fraction here when we're done. So let's tackle the housekeeping stuff first. On the left side, we have a y plus 4 to bring down. And then again, never in the history of mankind has anyone wanted clarification on the yellow arrow. It's just negative 1/2 stuck to x. So we got our slopey part. Now comes the bad part. It's the red arrow of doom. But again, you just, if you're willing to play along, you can't not get it if you just do this. Take your fraction, write it down. Don't worry about negatives. We'll tackle that in a bit. Don't worry about that nonsense. Let's just worry about the numbers. And what am I going to write 3 as? And at that point, I see why there's no compatibility. I see the 3 and the 2 not being able to reduce. What am I going to get? What's 1 times 3? 2 times 1? 2. So I know I'm going to put a 3 halves here. The question becomes, should I put a plus in front of it or a minus? Definitely a plus because of the two things that I'm circling in green. That's a negative multiplier and a negative multiplyee. And when two negatives multiply, they make positivity. Now, I've got a math, which means I need to solve the equation, which means I need to subtract 4 from both sides. Now, see if you can help me with this. I am not going to subtract, air quotes incoming, 4. What am I going to subtract? 8 halves. Because 4 is 8 over 2. 4 is a chameleon. Every number is a chameleon. You don't want the number 5? Multiply it by 3, and you got 15 thirds. You don't like 8? Multiply it by 9. You got 72 ninths. Like any number is a chameleon. Any number can be written however you want to suit your needs. But in this case, 4 says, let me be an 8 halves so I can play nice with this other guy. Which leads us then to the answer, which is y equals negative 1/2 of x minus 5 halves. Nice. Okay. Let's do another one. Y plus 11 equals negative 2 thirds times x plus 9. Quickly assess it. And if you don't know what I mean, because I know a lot of you don't like talking during class, make sure you advocate for yourself sometime today. Come talk to me if you're bashful. Is that a friendly fraction or an evil fraction? He's very friendly. This fraction is going to cause me no grief at all. And the reason I know right away is because 9 says, yeah, we're good. I can divide by that, dude. So off to the side to help you guys who might be a little bit confused, I'm just going to write it down. 2 thirds times 9. You got options with numbers. These are little baby kitty numbers. You can multiply it and reduce, or you can reduce and then multiply. If you're a reduce and multiply person, then you're going to knock the 9 and the 3 both down by 3. If you're not like one of those people, then you're going to go like this. What's 2 times 9? What's 3 times 1? What's 18 thirds? 6. Okay, so the result of this red arrow is the number 6. Positive 6, negative 6. We'll cross that bridge in a moment. So what I currently have is y plus 11 equals negative 2 thirds of x. Is it a plus or a minus? It's a minus for sure. And again, I could point you to these signs. That's a negative multiplier and a positive recipient. A negative and a positive have always multiplied to make a negative. And like I said, the answer is that. Friendly fraction. Nice. So now when I move the number to the other side, I don't have to worry about all that denominator nonsense. What are we going to do to both sides? Good. And we're left with y equals what? Done. So throughout the assignment, you're going to see three types of problems. You're going to see problems like this with friendly fractions. You're going to see problems like this with evil fractions. And of course, you're going to see problems like this with no fractions. Okay. Those are the three flavors that you'll be tackling after the quiz today. Any questions about that? Okay. This is really important because after today, everything we do, pretty much everything is going to be converted to slope intercept. So if you're struggling with this, don't just struggle in silence. Let me know because it'll be an everyday thing from now on. All right. Number two. Would you read it to me? Mine is over there. I'm ready. Good. So we can see right away that this is, thank you, that this is not a nice fraction, is it? And sometimes people fall for it and think, oh, what 8 can be divided by 4, but I'm not interested in that. I'm interested in the fact that 4, when I try to divide it by 8, isn't going to come out nice, right? You can't divide 4 evenly, $4 by 8 people or whatever. So that's why we know we're going to be dealing with fractions. Okay. If the 8 and the 4 would switch places, then this would be a better situation. So I'm going to copy down the y plus 2. And then again, the yellow arrow is the light work. That's easy. I just put negative 3/8 of x. It's the other part that is a problem, and that's the red arrow. And what I'm trying to do when I kept showing you how to do this was just empower you to always be able to do this. So the way to do it until eventually you get quicker, you do enough of these, you just start to see things, I think. I just would take the 3/8, write it down, take the 4, write it down, and then just math. So at this point, again, you have to decide which kind of person you are. Are you a reduce then multiply person or a multiply and reduce later person? Okay, well, since you ghosted me there, I'll just tell you what I like to do personally is reduce before I multiply. For me, it's an old habit that it keeps me from ever having to work with numbers that are too large because I hate calculators. They're terrible tools. So me personally, I'd rather never have big numbers. So I'm going to identify that the 4 who's on the top floor of the hotel and the 8 who's on the bottom floor of the hotel can both be divided by 4. So I'm going to personally knock the 4 down to a 4 divided by 4, 1, and the 8 is going to be an 8 divided by 4, 2. I like doing it that way better because I'd rather reduce while the numbers are smaller instead of instead of putting them together and getting bigger numbers. And that's probably just a result of working with teenagers for 30 years. Um, so I maybe do things the way I would expect my students to, but that's what I would do. So at this point, I'm going to multiply across the top. 3 times 1 is 3. And then across the bottom, 2 times 1 is 2. The only decision for me left to make once I put my 3 halves here is will I put a plus sign or a minus sign? A minus for sure, because the multiplier is a negative and the multiplyee is a positive. Positive times a negative or negative times a positive, whatever is a negative. So this is the way problem 2 looks after one step, which eventually you'll see becomes the easy step, right? It's this next one that I spend a lot of time every year trying to coach people through. I have to subtract 2. I'm putting 2 in air quotes here because the number 2 is a chameleon. The number 2 can be whatever you want him to be. Um, the number 2 can equal 2 over 1, 4 over 2, 100 over 50, 86 over 43, negative 8 over negative 4. It could be 34 over 17. Everything I just wrote, every single thing I wrote over here equals 2, right? It's the magic of a numbers. You can make it look however you want, as long as it still equals the same thing. In this case, my guy is the one in the red box, and I pick him because he's got a 2, and the one I'm going to target has a 2, right? So when I subtract 2 from both sides like this, I'll show -2 on the left, but I'll show -4/2 on the right. They're the same, but I have to play nice. In the land of fractions, you just have to follow the rules. And adding and subtracting, the rule is you need a common denominator. Okay, apples and apples. So these are going to go away, and we're going to be done. We're going to have y equals -3/8 of x minus something over 2. And it's just at this point, basic, basic, basic math. We start at -3 and we take away 4. What is -3 minus 4? See, you can't do, it just can't do that. You can't do that either. That's even worse. -3 minus 4 means that a football team went up to the line of scrimmage, quarterback took the handoff, was hit pretty quick, lost 3 yards. And on the next play, same thing happened. They tried to run the same play, and the same thing happened. The offensive line broke down, crashed through. They sacked the quarterback for another loss. And when you lose 3 yards and you lose 4 yards, you have lost a total of 7 yards. That can never be -1. It can never be +1. It can never be +7. So, so much of math boils down to just our ability to function, plus and minus function. And you're usually pretty good with that. That was a little rough though. So that's how that goes. Got it? You sure? Okay. What I find with this lesson is that it's very little about how to convert point slope into slope intercept. As with everything I do for a living, it winds up 98% existing around conversations about fractions and adding and subtracting. So please continue to ask. I will give you some more time to work on assignment 33, just for your planning and preparation.